What's up guys, and welcome back to the Calculus Stories channel. Now in this video, we'll go ahead and focus on solving three exercises that are trigonometric and exponential in nature. And so let's go ahead and look at our first example. In our first example, we have a function f of x, which is 2 times sine of x times cosine of x minus cosine of x. And we want to go ahead and solve for x when f of x assumes a value of 0 on the interval 0 to pi over 2. Now, in this exercise, there is unfortunately a wrong approach to solving an equation like this. So let's go ahead over the wrong approach first, just so that you can go ahead and avoid these mistakes when solving these equations. And so let's go ahead and set up our equation, which is 0 is equal to 2 sine of x cosine of x minus cosine of x. And so by crossing over cosine of x over to the other side by addition, we'll get cosine of x is equal to 2 sine of x times cosine of x. Now, if you go ahead and divide both sides by cosine of x, you'll get 1 on the left-hand side is equal to 2 sine of x. And so finally, by dividing by 2, you'll get the equation sine of x is equal to 1/2. And so on the unit circle, sine of x has a value of 1/2 at an angle of x is equal to pi over 6. But our approach to solving the equation in this way is an incomplete solution set. And you'll go ahead and find out why in just a second. And so the correct approach to solving this type of equation is by means of factoring. So we'll go ahead and set up our equation, which is 0 is equal to 2 sine of x cosine of x minus cosine of x. And so by factoring out cosine of x, we can go ahead and rewrite our equation in the following manner. 0 is equal to cosine of x, and when you factor out cosine of x, what's left behind is 2 sine of x minus 1. And so by writing our equation in this way, we know that whenever cosine of x is equal to 0, the whole equation will be 0. And similarly, whenever 2 sine of x minus 1 is equal to 0, the whole equation will also be equal to 0. And so we can go ahead and write the following equations. Cosine of x is equal to 0, and 2 sine of x minus 1 is equal to 0. And we can go ahead and find those x values that will make these equations 0. And so for the first one, we know that cosine of x is equal to 0 at an angle of x is equal to pi over 2. For our second equation, we can go ahead and cross over 1 to the other side by addition. And so we'll have 2 sine of x is equal to 1. And by dividing by 2, we'll go ahead and get sine of x is equal to 1/2. And so on the unit circle, sine of x is equal to 1/2 at an angle of pi over 6. And so these two x values, x is equal to pi over 2 and x is equal to pi over 6, are our solutions that make our function f of x equal 0. Alright, so let's go ahead and jump into our second example. In this example, we have a function g of x, which is 8e to the 3x power minus e. Now, we want to go ahead and solve for x when g of x assumes a value of 3e. And so let's go ahead and set up our equation. Our equation is going to say 3e is going to be equal to 8e to the 3x power minus e. And so if we want to go ahead and solve for x, we're going to have to take those steps to isolate x. And so let's go ahead and get rid of that minus e by crossing it over to the other side through addition. And so by adding e on the right hand side, minus e and plus e will go ahead and cancel out. And on the left-hand side, 3e plus e is 4e. And so we'll have our equation 4e is equal to 8e to the 3x power. Next, let's go ahead and get rid of that 8 by dividing both sides by 8. And so on the left-hand side, when you divide 4e by 8, what you'll get is e divided by 2. And on the right-hand side, when you divide 8e to the 3x power by 8, the 8s will cancel out and you'll just be left with e to the 3x power. Now, we're almost to that point where we have x by itself. All we have to do is get rid of the e. Now, to get rid of the e, we have to do the inverse operation of e, which is the natural log. And so by taking the natural log of both sides, we'll end up with the equation ln of e over 2 is equal to ln of e to the 3x. On the left-hand side, we can go ahead and use logarithmic properties to rewrite ln of e over 2. And ln of e over 2 is just ln of e minus ln of 2. And on the right-hand side, when you take ln of e to the 3x, all we're left with is 3x. Alright, so let's go ahead and simplify this a bit more. So when you take the ln of e, all you're left with is 1, and then you'll have minus ln of 2 is equal to 3x. Now, to go ahead and solve for x, let's just go ahead and divide the whole thing by 3 to go ahead and get rid of the 3. And so when we divide both sides by 3, what you'll get on the left-hand side is 1 over 3 minus ln of 2 divided by 3 is equal to x. Alright, so for our last example, we have a function h of x, which is equal to cosine of 2x plus 4. We want to go ahead and solve for x when h of x assumes a value of 9/2. So we can go ahead and set up our equation and say that 9/2 is equal to cosine of 2x plus 4. And so to go ahead and start solving for x, let's go ahead and get rid of the 4 on the right-hand side by subtracting. And so by subtracting, on the left-hand side, we'll end up with 9/2 minus 4 is equal to cosine of 2x. Now, let's go ahead and simplify the number that we have on our left-hand side by turning 4 into a fraction with a common base. And so you'll have 9/2 minus 8 over 2, which is essentially 4, is equal to cosine of 2x. Alright, so on the left-hand side, when you subtract 9/2 minus 8 over 2, you'll go ahead and keep the same base and just subtract the numerators. And so you'll have 9 minus 8 all over 2 is equal to cosine of 2x. And so if you simplify the left-hand side, 9 minus 8 is just 1 over 2 is equal to cosine of 2x. Now, before we can go ahead and solve cosine of 2x equal to 1/2, let's go ahead and consider our original cosine function cosine of x is equal to 1/2. Now, from the unit circle, we know that cosine of x is equal to 1/2 at an angle of x is equal to pi over 3 and x is equal to 5 pi over 3. And so for this example, we want cosine of 2x, the number within the parentheses, to be equal to pi over 3 and 5 pi over 3 for an appropriate x value. And so since we want 2x to be pi over 3 and 5 pi over 3, we can go ahead and write the following equations. 2x is equal to pi over 3 and 2x is equal to 5 pi over 3. Now, let's go ahead and start solving our first equation. 2x is equal to pi over 3. So to solve for x in this situation, all we have to do is get rid of the 2, which we can do by multiplying by 1/2 on both sides. And so we'll have 1/2 times 2x is equal to pi over 3 times 1/2. And so on the left-hand side, all you'll be left with is x is equal to pi over 3 times 1/2, which is pi over 6. And so for our second solution, which is 2x is equal to 5 pi over 3, we'll go ahead and multiply by 1/2 on both sides. And so we'll have 1/2 times 2x is equal to 5 pi over 3 times 1/2. And so on the left-hand side, all you'll be left with is x. And on the right-hand side, 5 pi over 3 times 1/2 is 5 pi over 6.